Alright guys, welcome back. We are on 1.8. We're talking about one variable inequalities. So we've mentioned this, but today we're going to get into it a little bit deeper. So inequality symbols are used to describe solutions. Okay, so sometimes it's not always going to be equal to. Okay, so we are used to seeing these symbols, but what's also more important, if not at least as important, is how to read it, right? So we have greater than. When we are pointing to the right, we are greater than. For example, x is greater than 5. Okay, and what that tells us is x can be any number greater than 5, but x cannot be 5. Okay? So that leads us to our next step, greater than or equal to. So notice we add a little line underneath there, and that tells us we're greater than or equal to. For example, x is greater than or equal to negative 4. Okay, so now with that line down there, we can be negative 4, but we can also be any number greater than negative 4. Our next two are similar but opposites, right? So we have less than. Remember that symbol points to the left, if remembering that L's will help you. So x is less than 7, and this says that x can be any number less than 7, but x cannot be 7. Which leads us to our last symbol, less than or equal to. So notice we add our little equal to under there one more time. Okay, so now we've got x is less than or equal to 2, and that tells us that x can be 2, or it can be any number less than 2, so it could be both. All right, so let's look at these next examples and determine whether each value is a solution to the inequality. Okay, so our first example, is negative 3 a solution to x is less than 4? Okay, so if we know we've got x is less than 3, well, is that greater than or less than 4? Picture a number line in your head, right? So negative 3 is less than 4, so this is true. For B, we've got is 50 a solution to x is greater than 75? Okay, so let's write it out and fill it in, right? So we've got 50 and we've got 75. Well, is 50 greater than 75? No, 50 is less than, right? So the answer for B is no. It is not a solution. 50 is not greater than 75. Looking at C, is negative 123 a solution to x is less than or equal to negative 300? Okay, so I know that negatives can be confusing, but remember, just picture the number line in your head. So negative 23 is going to be somewhere right here. And then further down, we'll have negative 300. So is negative 123 a solution? It is not a solution, right? If you picture that number line in your head, that looks crazy. If you picture that number line in your head, negative 123 is not less than or equal to negative 300. Okay, and our last example, is 87 a solution to x is greater than or equal to 87? Okay, keyword that we're looking at here, greater than or equal to 87. Okay, so that means that we can equal 87, or we can be any number greater than 87. Okay, well in this case, 87 is 87, so yes, this is a solution. All right, so now let's talk about how to represent those solutions for one variable inequalities on a number line. Okay, so we know that we can picture the number line in our head for help on which symbol we're going to use, but we can also actually graph that on the number line, right? So each symbol is going to have a different way to graph it on a number line. Okay, so for greater than and less than, for both of those, we graph it with an open circle. Okay, open circle. And then the question asks us, is the circle number a solution? Okay, well, when we're greater than or less than, we know that we can be any number greater than that number or less than that number, but we cannot equal that number. So when it says, is the circle number a solution, both of those are going to be no. okay? And that's what exactly that open circle means. It means that there is not a solution, right? So on our next two, when we're greater than or equal to, or less than or equal to, now notice we fill that circle in. And when we fill that circle in, it tells us that the circled number is a solution. Okay, so because it's filled in, we know that it's going to be either greater than or equal to, or less than or equal to. It's definitely going to be possible that it can equal that number that's circled, right? Okay, so inequalities are graphed because they have infinitely many solutions. All right, so let's look at our first example. We have 2x minus 17 is less than negative 9. Okay, so what we're doing is still solving for x, right? So we still have to isolate the variable. So we're going to start by adding 17 to both sides. Okay, that clears it out on the left for us. Negative 9 plus 17 leaves us with 8. So we've got 2x is less than 8. Just treat it like it's an equal sign in the meantime. Just solve for x, right? So to get rid of 2, we are going to divide by 2 on both sides. So we're left with x. 8 divided by 2 leaves us with 4. So x is less than 4 is now what we have to graph, right? So we find that boundary point, right? Meaning we can go all the way up to 4. And then we're going to graph it with an open circle because we're less than. We are not less than or equal to, so 4 cannot be a solution. And then because we're less than, we graph everything that's considered less than, right? Which we shade to the left for less than. All right, so let's try one example together. Okay, so we've got negative 2x plus 18 is greater than or equal to 6. Okay, so we're solving for x. So the first thing we need to do, just like we would with a regular equation, we're going to get rid of that 18. So since we're adding 18, we're going to subtract 18 from both sides. Okay, so then we're left with negative 2x. It's greater than or equal to 6 minus 18 leaves us with negative 12. And now we're going to solve for that x. So to get rid of that negative 2, it's being multiplied, so we're going to divide it. Okay, and remember your rules with inequalities. When we multiply or divide by a negative, we have to flip our inequality symbol. Okay, so our greater than or equal to now becomes less than or equal to. We're left with x on the left side, and negative 12 divided by negative 2 leaves us with positive 6. Okay, so now we can go to graphing, right? And 6 is going to be our boundary point, so we find positive 6 over here, and we are less than or equal to. So because we have that equal to, this is going to be a closed circle. Oh, not zoom. Okay, and we're still less than, so we're going to shade to the left. So everything to the left gets shaded. Hopefully yours looks a little bit better than mine. Okay, so the biggest thing here is to make sure you're shading to the correct side, left side for less than, right side for greater than. And if it's not equal to, you have an open circle. And if it is equal to, you have a closed circle, and that is a solution. Also, don't forget right here, our box on the bottom, if you multiply or divide both sides by a negative number, you must flip the inequality symbol. So that's very important. Go ahead and look at your practice and give this a try.